Okay, super duper, here we are on question 8. This is an experiment that we have actually done, so that's lovely. So just skimming through the question, we've got photosynthetic activity of isolated chloroplasts indicated by the reduction of a dye. DC pip. When oxidised it's blue, when reduced it goes colourless. So we're going from blue to not blue. And of course remembering that you've got chloroplasts in there as well, so it's kind of a bluey green. And we've got a graph. So we got the transmission. Remember, transmission is the light that passes through a solution. So it will be low for the blue and high for the colourless. And we've got all these different tubes. We need to complete them right. Okay. So starting with the question. Name the mineral ion that is required for chlorophyll synthesis. Chlorophyll, magnesium. Easy peasy, AO1, 1 mark. Okay, so we're now looking at this experiment. So we've got buffer and DCP in this one, but no chloroplasts. So if you remember from the experiment, we said that was to show that the DC pip doesn't sort of spontaneously decolorise. So without chloroplasts, even if it's in bright light, no decolorisation. We've got now chloroplasts and DC pip, and chloroplasts we know give off electrons. They're in bright light, so they're doing that. So we've got electrons emitted. That's going to decolorise. Boiled. Placed in bright light. So boiled will disrupt all those proteins in the membrane, probably the chlorophyll as well. Pretty much boiling things stops them happening, so we'll say no. And then darkness, we're going to get no light dependent reactions. And that's where the electrons are coming from, so they're not going to change colour either. And if you remember, we covered our tubes with foil, probably lots of foil, probably too much really. So explain the difference in transmission. So what's the difference in transmission observed? So tubes 2 and 4, so we're looking at that line. Tube 4's across, so that's pretty much just a straight line, isn't it? So
Excuse me, Miss Lord. Do you know where Mr. Schofield is? Dr. Schofield?
not off the top of my head, no idea.
Alright.
Sorry about that. There you go. So, where was I? Explain the difference in transmission. Luckily you won't have any distractions and students knocking on doors asking random questions. So, flat line from 30%, so this, I'm going to do tube 4 first because I think it'll be easier. So, in tube 4, there is no change in transmission as the DC pip is not decolorized. I've got to explain because there is no light for the light dependent reactions. That's dealt with, that one. now to in tube 2, and I'm going to have to tell a bit of a story here, aren't I? So I'm going to have to say something about the I'm going to have to say something about light, chlorophyll, electrons, reduction, colourless, increase in transmission. I can tell that story either way. I could start with the increase in transmission and work my way backwards, or I can tell it forwards. I'm going to tell it forwards. So, in tube 2, the chlorophyll can't spell chlorophyll, absorbs light and emits electrons. Light should be energy, of course. Or you can put photons. And emits electrons. The electrons, so here we've got this. Okay, so when reduced by gaining electrons, so the electrons, just checking, reduce the DC pit, and it becomes colourless, as the solution becomes colourless, more light gets through, and the transmission percentage increases. Job's good. And there are 5 marks for that, so you know there's very little you can say about tube 4. That's going to be 1 or 2 marks, and then the rest of it is going to be for that sort of story going on. Okay, moving on. The Kelvin cycle is outlined in the diagram below. So here we've got, we've been given it, so that's good. It's our enzyme, Rubisco. That's carbon dioxide fixation. Got ribulose bisphosphate. Anyway, right, complete the diagram. So I don't want to write too much on it, just in case. I want to show where reduced NADP is required. So what do I know about reduced NADP? Reduced NADP reduces GP to TP, so it's going to be somewhere in between. So I'm going to put a little curly arrow. NADPH gives NADP. Yep. Where ATP is required, so I know that that requires energy. I'm going to put some ATP in there, get ADP and phosphate out. But this one's for 2 marks, so there must be somewhere else. So let's keep on going round. So not used there, that's just unstable and it splits, and it's used there. So it's either there or there, but it doesn't take any energy to join RUBP to carbon dioxide, so that is the regeneration, isn't it? Got ATP going in there. Identify a 3-carbon compound. That could be this one or this one. Just one of them will do. And a 5-carbon compound, so this is our unstable intermediate, which is 6 carbons. Don't want my examiner to be looking at that or that. So 6, 3, 3, regenerate 5 carbons. Excellent. The enzyme Rubisco is able to catalyse more than one reaction. Joy! In addition to its role in the Kelvin cycle, it is able to catalyse the combination of oxygen. So instead of having RUBP plus CO2 gives 6 carbon thing, we've got now Rubisco, got RUBP plus oxygen gives who knows what. But nothing that's going into there, that's for certain. This has the effect of the cells taking up oxygen and releasing carbon dioxide. So this is like respiration, isn't it? When exposed to very bright light. And this is known as photorespiration. Using this information suggest why, so why, I'm going to have to write a because thing, is a disadvantage. So, RUBP, so we'll start there. Bonds to oxygen, so less bonds to carbon dioxide. Makes sense, doesn't it? If you've got some bonding to oxygen, you've not got as much carbon dioxide coming on. So less CO2 is fixed. Remember, I have my carbon dioxide fixation up there. So what will that mean? We've got less carbon dioxide fixed, less unstable intermediates, less glycerate phosphate, less triose phosphate, and of course what we're using our triose phosphate is to make sugars. So and less, we're slowing everything down. Calvin cycle slows down, and less products of photosynthesis can be made. Why have they told us about that bright light? Very bright light should enable more photosynthesis, but photorespiration means less. So plants can't use the extra, because it's very bright light energy. That kind of wraps it up for the disadvantages.